For the rhombus, we need to know the definition of a rhombus. Rhombus means a quadrilateral with 4 sides equal to one another. So, according to the definition, if we have known this is the rhombus, we can get the conclusion: the 4 sides AB equal to BC equal to CD equal to DA. This is the definition of the rhombus. Now, with this prerequisite, we can figure out the following conclusion. First, we focus on 2 triangles. Triangle ABH and triangle ADH. In these 2 triangles, we have known AB equal to AD, AB equal to AD, and AH is the common side for this triangle and this triangle. So AH, they are equal to each other. Additionally, we can figure out angle 1 equal to angle 2. Why? Angle 1 equal to angle 2. If we can prove angle 1 equal to angle 2, we can make use of the 3 conditions to figure out triangle ABH congruent to triangle ADH. So now we need to prove this conclusion. Angle 1 and angle 2, they are respectively in two triangles. Angle 1, for this triangle, angle 1 is an interior angle. Angle 2, for this triangle, it is the interior angle. So we have known this 1 equal to this 1. This is the common side for the 2 triangles, and BC equal to DC. So we know AB equal to AD, AC equal to AC, BC equal to DC. We get the triangle ABC congruent to triangle ADC. For 2 congruent triangles, we can figure out the corresponding angles should be equal to each other. So angle 1 equal to angle 2. Okay. Now we know this conclusion exists. So from this prerequisite, and this prerequisite, we can figure out the conclusion that you say triangle ABH congruent to triangle ADH. So we write it here, they are congruent to each other. So for the corresponding sides for these 2 congruent triangles, we can figure out BH equal to HD. That you say the point H is the midpoint of this diagonal. Additionally, we know the corresponding angle BHA equal to angle DHA. Additionally, these 2 angles, their sum equal to 180 degrees. So we can get the following conclusion. That you say, angle BHA equal to angle DHA equal to 90 degrees. So we get AC perpendicular to BD. Similarly, we can prove AH equal to HC. Why? Because AD equal to DC and HD is the common side for these two triangles. And this angle, they are equal to each other. So for two right triangles, if we have known the hypotenuse are equal to each other, and this is the common side, we can figure out these two right triangles, they are congruent to each other. So the corresponding sides, that you say, this side AH equal to this side HC, right? So we get this conclusion because the right triangle ADH congruent to the right triangle CDH. And from this conclusion, we get AH equal to HC. So H is also the midpoint of this diagonal. So we can get the conclusion that you say AC perpendicular to BD, additionally AC and BD bisect each other. So we can regard it as the property of the two diagonals. This is the first property. This is the second property.